So I've been tinkering with a proposal for enabling origin-based filtering of requests on the server side designed for privacy in mind. So say I pop up in Firefox and navigate to my favorite online egg buying website. Firefox sends off requests to a remote server, and the server sends back some HTML for the site's order form. I fill in my information, and I click on that submit button, and Firefox then posts the information off to the remote server, along with an HTTP cookie header containing my logged-in authentication token, so the site can match up the purchase order with my account and charge the correct credit card for these eggs that I'm buying. Now the server sends back some HTML saying my order has been placed and presumably some eggs get sent to my doorstep. But now, say some egg-loving fiend sets up their own evil website to victimize people like me, who happen to be logged into buyeggsonline.com in Firefox or whatever browser. If I'm lured into visiting this evil website, it posts off its own request from my browser to buyeggsonline.com's checkout endpoint. Now, because this request is still going to buyeggsonline.com, Firefox dutifully attaches that same authentication token in the cookie header, so my credit card gets charged for the order, even though the attacker has pre-filled their own address, so the eggs get sent to their house instead of mine. Now, we're proposing to fix situations like this by, well, tacking on another HTTP header. A very simple one we call sec_same_origin, which is just 1 for same-origin requests or 0 for cross-origin requests like this one. And in this case, the server could inspect that header, see this as a cross-origin request, and block it from being processed, saving me my egg money. So this header essentially just encodes one bit information, which is a desirable property in terms of privacy and bandwidth efficiency. For privacy, compared to the HTTP referrer header, which leaks full page URLs and is commonly abused for tracking users' web history online. For bandwidth efficiency, with HTTP header compression, we ought to be able to crush this effective one bit of information down enough to be feasible to include this header by default with each request the browser sends off. But now, in some situations, you actually need to know more than just whether a request is same or cross-origin. For example, say I run my own little webcomic at mywebcomic.com. But for performance reasons, I host the actual comic image files, because they're relatively large, on an external CDN like Amazon S3, which bills me for every byte of image data it serves. Importantly, those images end up getting served from a different origin from my main website, the CDN's origin instead of mywebcomic.com. Now say one day I come up with a particularly funny webcomic and post it to my site, and some random content blogger stumbles across it, and they do what content bloggers sometimes do. They right-click and do copy image location, and copy that CDN image URL and slap it into their own website. And this is exactly what happened to the webcomic The Oatmeal, whose author got stuck with a $1,000 AWS bill, serving traffic coming from a hot-linked image from the Huffington Post. Now, the sec_same_origin header doesn't help in this situation because the legitimate requests coming from mywebcomic.com are themselves cross-origin. What we'd really like to have in a situation like this is a textual origin header, saying that these GET requests are coming from mywebcomic.com and not from some random blog, which we'd like our CDN to block. However, it's not really feasible for the browser to include a full textual origin header with every request it sends out, both for privacy and for bandwidth efficiency reasons. Instead, we address this by introducing a new disclose origin attribute, sort of inspired by CORS, which you can slap onto like an image tag or a form tag or an iframe, so the referring page signals to the browser that it'd like to opt into sending the full textual origin along with this particular request to the external server. So we end up with a nice little model for providing servers with the right contextual information on where requests hitting them are coming from, which they can use to make security decisions. To evaluate this model, we implemented setting these headers in a little fork of Firefox, and then we implemented handling the headers in some web app stuff. For example, we took CSRF, a popular anti-CSRF middleware for Node.js, and replaced its whole 1,600-line crypto cookie token anti-CSRF implementation with just a simple header check that boils down to 3 lines of non-boilerplate code. We also took WordPress, which powers something like 25% of the internet, and started digging into its anti-CSRF code. And we actually found a number of new CSRF holes there. And so we stripped out the whole complex token-based anti-CSRF system they had, we dropped 900 lines from their code, and replaced it with some simple header checks which systematically fix all the CSRF bugs. We also took Minio and a self-hosted Amazon S3 clone and implemented the sort of disclose origin header hot linking protection to that. And we took the OAuth2 protocol and used the same header scheme in order to mitigate a known CSRF-like pitfall in that protocol. Now, some of you might be thinking, didn't we fix this already? Well, what we have right now is a grab bag of different tools in this area of web security, and each of them has its own caveats attached, which makes it not really an ideal solution, and each of them also only really targets only one specific pace, like CSRF, of what I see as a more general problem, which is servers not having enough information about where the requesting them come from in order to make security decisions. Brief thing before I get cut off here, is that one of these things, the origin header, is standardized already, and is also, we have an origin header-like thing in our proposal, but as standardized, it only applies to non-GET requests, so it is too narrow to help with things like hot linking. It is also apparently too broad, because we are now looking at blocking it whenever we block the refer header, which sort of defeated the whole point of introducing it in the first place, which is as a thing that we would send when the refer header was blocked. We had some other stuff in the paper, but no time to talk about that, so talk to me later.